And once you get into fights,
today I request students to maintain good silence. I am not keeping fit. Today I am having fever. Nevertheless, I wanted to cover two things. Okay. So please kindly cooperate. Okay. Two things I want to cover. Good morning. Let me just complete the admission process. Two things I try to cover. Yes. We need to wait for a couple of minutes so that all admissions are over. Then we can go to methods of separating the mixtures. Often in organic reactions, you get more than one product, and you require to separate whatever you want from whatever you don't want. So, how to separate a mixture? The names which we talk are sublimation, distillation, fractional distillation, steam distillation, distillation under reduced pressure, chromatography, solvent extraction. These are the methods normally employed to separate mixtures of organic compounds. Let us be familiar with names. Sublimation. If a solid is heated, directly if it becomes gas, this phenomena is called sublimation. Some organic compounds like benzoic acid, camphor, naphthalene, these are sublimable solids. If they are present with other impurities, other salts which don't have this property, so benzoic acid can be separated from impurities by sublimation, camphor can be separated from impurities by sublimation, naphthalene can be separated from impurities by sublimation. Sublimation is simply heating where a solid becomes gas. Yes. You take the naphthalene plus impurities in a china dish, put a funnel like this and put it on a stand, heat. When you are heating, only naphthalene will become vapor and touch the surface of funnel. There it becomes solid. After some time, you open the funnel and scratch it. Open the funnel and scratch it. You get a pure naphthalene. This method of separating one component which is sublimable from its impurities is called sublimation. So, which fellows are purified by sublimation? Naphthalene, camphor, which you use, camphor, white solid, and benzoic acid. There are many sublimable solids, but we take these three. Very known to you. Naphthalene balls are used to kill moths in our suitcases, in our dress racks. White naphthalene balls are also kept in sinks and toilet seats. That naphthalene is a sublimable solid. Now distillation. When you have salt water, if you want to have pure salt, you can distill the water out and you will be left out with salt. Distillation means simply heating and removing the liquid component as a vapor. Whereas if you have three different liquids, water, alcohol, and say aniline, water, alcohol, and phenol, this mixture of three components, all are liquids, can be separated by what is called fractional distillation. Petroleum is separated into different components using fractional distillate. In fractional distillation, you take a round bottom tube in which you take a mixture. Here you fit a long glass tube. This long glass tube has fractionating column. There are so many curvatures. When the vapor is going through all this, whatever that has lower boiling point will reach the top and remain as gas. Whatever that has higher boiling point will remain as a liquid in bottom. So in fractional distillation, the vapors which go up the top position have least boiling point. Here whatever that comes has lower boiling point. Here whatever that comes has high boiling point. So like you put different openings at different heights, and you can separate the different components which are differing in the boiling points. So fractional distillation is a technique of separating liquids whose boiling point differs narrowly. There are different designs of fractionating columns which we see. Okay. Now you have steam distillation. You pump the steam into, say, nitrobenzene plus impurities. You want to get nitrobenzene. So this nitrobenzene fellow will go out along with the steam, because whenever the steam is pumped into nitrobenzene, vapors of nitrobenzene, vapors of water get the pressure equal to that of atmosphere. P is equal to P1 plus P2. Partial pressure due to vapor of nitrobenzene. P2 is equal to partial pressure due to vapor of water. When P1 plus P2 value is equal to 1 atmosphere, that mixture will come out. When that mixture comes out, you take it in a funnel like this. It has an opening here, it has a tap here. This is called separating funnel, and in this, nitrobenzene is not miscible in water. Therefore, water is coming bottom as a layer and nitrobenzene is another layer. Like if you have oil and water, oil is bottom layer and water is top layer, like that. In the separating funnel, you put the mixture of immiscible liquids. If you open the tap in the bottom, whatever the fellow which is there in bottom will come out first. So a mixture of immiscible liquids can be separated by using separating funnel. Now you have another method. There is some liquid called glycerol. Hydrogen peroxide is another liquid. Ethylene glycol is one more liquid. These liquids are very crazy that if you simply heat them, they break down, they decompose before they boil. Before you can achieve their boiling, they decompose. They lose their identity. So some liquids have high boiling points. When you try to boil them directly, they decompose. Water is not having that problem. If you try to boil water, water would not decompose at its boiling point. But glycerine, hydrogen peroxide, ethylene glycol, they decompose. Such liquids which decompose at their boiling point can be separated and purified by distillation under reduced pressure. Notice, if you are decreasing outer pressure, the boiling point of liquid drops. Sir, do you know what is the boiling point of water? What is the boiling point of water? Hello?
100 degrees.
100 degrees
But we
Celsius.
can make water to boil at 2 degrees centigrade. Do you know? You can make water to boil at 1 degree centigrade. You can water to boil at 50 degrees centigrade. How?
By changing pressure.
By lowering outer pressure. If you take water into an open space where the pressure is zero, immediately it will become vapor even at 0 degrees centigrade. So by lowering the pressure, you can drop the boiling point of liquids. This is called distillation under reduced pressure, so that the compound that decompose at its normal boiling point can be safely separated. When you are trying to make soap, you can make soap, toilet soap you can make at your home. You can take any damn oil like coconut oil, groundnut oil, any oil. You can add any base like washing soda or baking soda and boil. If you boil a solution of washing soda and oil together, you will be getting soap. You can add a bit scent if you want to have pleasant smell. The solid soap gets separated. Along with solid soap, a liquid will be released called glycerin. After removing soap, whatever you are left out is called spent lye. It has a technical name, spent lye. Spent lye is remaining liquid after separating soap. Remaining liquid after removing soap. Then from spent lye, you can separate glycerin. What is glycerin? Prop 1,2,3 triol. OH, OH, OH. One can separate glycerin from spent lye by distillation under reduced pressure. When you are looking at these methods, there are some methods to separate organic compounds. Sublimation is for benzoic acid, naphthalene, and camphor. Distillation is to separate solids from their solutions. By distillation, you can remove liquid. Fractional distillation is to separate different liquid together, which are there in a mixture, whose boiling points differ narrowly. Petroleum is purified by fractional distillation. This is a diagram showing the sublimation method to separate. This is a diagram showing fractional distillation. And this is a separating funnel to separate immiscible liquids. And the distillation under reduced pressure technique is used to separate glycerine, hydrogen peroxide, ethylene glycol, etc. from their impurities. From the spent lye in soap industry, glycerol is separated by distillation under reduced pressure. There is another important method called chromatography. Chroma means color. This method was originally employed to separate mixtures of colored components. Today it is also used to separate mixtures of colorless components. For example, amino acids can be separated using ninhydrin. Let us see what is it. In chromatography, always you use something that flows, something that is mobile, a liquid, something that would not move. For example, you want to separate a mixture of different inks. For example, somebody mixed red ink with blue ink with green ink. He gave you a mixture. He asked you to identify which colors are there. What is the ratio in which I mixed? Simply you bring a special filter paper called Wattsman filter paper. Here you put a baseline with a pencil you can draw. Here you put a dot of mixture which you want to separate. This paper you put in a jar. In the bottom you put some liquid. The liquid is usually alcohol water mixture, for example. Now, when the liquid is going up through the capillary action into the filter paper, the liquid component touches the mixture. In the mixture, different components travel to different levels. This is the level to which solvent travels. The red color goes, the green color, blue color. We can clearly see three spots. The three different colored spots indicate, okay, the mixture given is red, blue, and green. You compare the distance traveled by one component to the distance traveled by solvent. A ratio of these two is called retention factor that tells you what is the proportion of each colored component in the mixture. This method of separating colored components using a filter paper and a suitable solvent is called as partition chromatography or paper chromatography. Here you are separating. Notice always chromatography has something that moves, a solvent or a eluent, and something that is stationary, that is here a paper. Instead of paper, you can take in a glass container, you can take a glass slide. The glass slide is coated with a paste of Al2O3 or SiO2, a thin coating. On the coating, this is a coating of Al2O3 or SiO2. This is a plate, thin layer, this TLC plate, thin layer coated plate. Here you put the mixture which you want to separate. Here you place a solvent. As the solvent is ascending, different components get separated as different spots. Sometimes, if this is colorless, you can use iodine vapors. You can put some iodine. Iodine vapors give clear-cut, identifiable spots. If this is colorless, it is difficult to identify spots. As many spots you are getting, as many components are there. So the mixture which you want to separate, that solution you put as a dot. Here you put a solvent in the bottom called eluent and you allow it to spread. Iodine can be used to identify the spots. If you are separating amino acids, you can use something called ninhydrin to identify spots. This is called thin layer chromatography. Sometimes you take a long glass tube which has a tap here to open. This is packed with Al2O3 or SiO2, and into this, here you will place a mixture of A, B, C which you want to separate. This column is not mobile, it is stationary, this pack of Al2O3 or SiO2. Here this is a mixture which you wanted to separate. On this top you put a solvent. The solvent starts flowing. When solvent is moving, component A gets adsorbed on the surface and starts moving. In ABC, it may be that A may be very firmly sticking to the Al2O3 surface. We say it is strongly adsorbed on adsorbent. When it is firmly fixed, then B and C are loosely fixed, they come down. So if you keep on adding small doses of solvent here and open the tap, from the bottom C comes first. When all the C is separated, then B comes. When all the B is separated, finally A comes. So using a column and a solvent, you can separate a mixture of ABC. This is called column chromatography. So chromatography is 100 varieties. High pressure, gas layer chromatography, thin layer chromatography, paper chromatography, column chromatography, so on. Nowadays, chromatography is a very important technique in separating organic compounds. Always in any chromatography, you have a stationary phase and a mobile phase. So that's a note on chromatography. These are some methods of separating organic compounds. Standard questions. Which technique of separation requires a stationary phase and a mobile phase? Answer is chromatography. Paper chromatography is what type of chromatography? Partition chromatography. In column chromatography, the column is made up of with what? Column is made up of with Al2O3 or SiO2. Separating funnel is used to separate what? Mixture of immiscible liquids. Compound that decompose it at its boiling point, like glycerin, is separated from impurities by distillation under reduced pressure. So this is a quick review on methods of separating. Now let us look at what the NCERT book says very quickly. Oh, now some students have joined. Congratulations. So this is now we are making a survey from the NCERT book. Very quickly, we have less time. We have to do a lot of work today. Sir, I am sorry if I am going fast. Am I going fast, sir? Hello? Are we going fast?
No, sir. No, sir. Not that.
No, sir.
Because this has relatively less significance, so we need to go a bit fast. Because a lot is there, a lot of chemistry is there. So it got hanged, I think. Let us see for a minute whether it opens up. So it is not responding. Now the next important thing I need to discuss is identifying extra elements in organic compounds. Now two students, if somebody joins it is getting confused. Now two students want to join. Okay. Start broadcast. Open. Yes, sir. Now we are looking at, yes, sir. This is the page I am talking to. This is an important. I think there is an internet problem. Okay, you can read it from textbook yourself. I am not able to show it because time is ticking away. I have to take you to different level. Now, let me continue my narration. Sir. Yeah, we have, it is not responding. Sir, organic compounds have, generally, any organic compound has what elements, sir? Any organic compound has what elements?
Carbon.
Every organic compound necessarily has carbon, hydrogen. In addition to carbon, hydrogen, they can have nitrogen, oxygen, sulfur, phosphorus, chlorine, bromine, iodine, carbon.
Saifuddin, please mute your mic.
Yes, sir. I can mute. I have muted all. Don't worry. The problem is my system is troubling. It is slow. Okay, sir. Organic compounds can have some elements other than carbon and hydrogen, like nitrogen, oxygen, sulfur, chlorine, bromine, iodine, phosphorus. These are called extra elements or heteroatoms. Extra elements or hetero. How do you know that the organic compound has carbon and hydrogen? How do you know? You take organic compound in a container and add copper oxide and heat. If you are heating, carbon of organic compound combines with copper oxide to give you copper plus carbon dioxide. Okay. The carbon dioxide gas goes out. Similarly, hydrogen can become H2O, vapor. How do I know that CO2 gas is coming out? Means if I pass the outcoming gases, the lime water turns milky. If lime water turns milky, definitely I can say CO2 is coming out. Similarly, how do you know that water vapor is coming out? A white copper sulfate when exposed to water vapor gives blue color CuSO4 5s2. If white CuSO4 gets blue color, definitely water is coming. Therefore, you take the organic compound, heat with copper oxide, pass the outcoming gases into lime water, check whether it turns milky. Pass the outcoming gases onto white copper sulfate, check whether it becomes blue. If answer is yes, you declare, okay, my organic compound has carbon and hydrogen. Very good. Then how to identify other extra elements? In the laboratory, there is a very small test tube of your half of little finger size. This is called Lessines tube. This Lessines tube, you take 0.5 gram of organic compound and 1 gram of sodium metal. And then you hold it with the tongs and start heating it so that it become red hot. When it become red hot, in this container you put some water, it is called mortar, and into this you throw the red hot tube. And using this pestle, you will grind it. What you are trying to do is, the sodium you are heating with organic compound which has carbon, and if it has nitrogen, you get sodium cyanide. If the organic compound has, say, chlorine, it will become sodium chloride. If the organic compound has, say, sulfur, it will become sodium sulfide. Like that, whatever the extra element that the organic compound has, you want to convert into sodium salt form. Once you are getting cyanide, you can easily identify whether there is cyanide ion. Once you get sodium chloride, you can easily identify whether it has chloride ion. Similarly, you can check the sulfide ion. How? You take lysine extract, you add ferrous sulfate solution, you add 1 drop of concentrated sulfuric acid. If you are getting deep Prussian blue color, cyanide ion is present, it implies organic compound has nitrogen. What is the test? Lysine extract plus freshly prepared ferrous sulfate and a drop of sulfuric acid. What do you observe? Prussian blue color precipitate. Why I am getting precipitate? If the lysine extract is having cyanide ions combine with ferrous ions of ferrous sulfate to give hexacyanoferrate complex. When you are adding a drop of sulfuric acid, concentrated, some ferrous ions will become ferric ions. These ferric ions combine with ferrocyanide. Fe has 3 positive charge. Ferrocyanide complex has 4 minus charge. So you put 4 here, 3 there. It is called ferrocyanide that has Prussian blue color. Therefore, simple, take the lysine extract, add ferrous sulfate, and then add a drop of concentrated sulfuric acid, check Prussian blue color or ferrocyanide, okay, cyanide is there, organic compound has nitrogen. If it has sulfide ion, take lysine extract, add a fresh lead acetate solution. There in your laboratory. When you add lead acetate aqua solution, immediately you get a black lead sulfide precipitate. If you are getting black lead sulfide on adding lead acetate, definitely lysine extract has sulfide ion, organic compound has sulfur. Also in the laboratory, you have a liquid called sodium nitroprusside. It is represented by a formula Na2FeCN 5 times NO. When sodium nitroprusside is added with sulfide ions, urgently it will become Na4FeCN 5 times NOS. which has a deep violet color. Therefore, if the lysine extract is added with sodium nitroprusside, be familiar with the name, sodium nitroprusside. If the lysine extract is added with sodium nitroprusside, if you are getting a deep violet color, definitely your organic compound has sulfur. And finally, if your organic compound has Cl, for example, it may have Cl minus, Br minus, I minus, I don't know. If the lysine extract has any of these, you add silver nitrate solution. If you are getting white AgCl that dissolves in ammonium hydroxide, chloride is there. If you are getting light yellow AgBr that is partially soluble in ammonium hydroxide, bromide. If you are getting yellow silver iodide precipitate that is not soluble in ammonium hydroxide, then iodide is there. So chloride, bromide, iodide can be easily identified by taking sodium extract, adding silver nitrate, and checking the color of the precipitate whether it is soluble in ammonium hydroxide. Similarly, phosphorus can be identified by ammonium molybdate. Directly you take organic compound and heat it with any peroxide, and then you add ammonium molybdate. If you are getting a yellow precipitate and adding ammonium molybdate, you conclude organic compound has phosphorus. So there are some standard tests to identify hetero elements or heteroatoms or extra elements in organic compounds. They are very simple ideas. Let us see whether we can open the textbook at this point of time. Yes. So I tried to read from the book. I'm not able to open the book, though I tried several times. So the weekend portion is up to the identification of elements, lysine test. Methods of separating organic compounds, lysine test, types of organic reactions. Only that is the syllabus. I don't know. I am having a temperature of 101 now. If my fever continues, I may not take class. If I am all right, I take class. Okay. So this is the syllabus I said. Don't ask me again. Syllabus is types of organic reactions, IUPAC nomenclature, intermediates like carbocations, carbanions, etc. And the types of organic reactions. And then methods of separating organic compounds. Yeah, we got open. Thank you. Yes. Let me see whether it moves. This is the page I wanted to discuss with you. Okay, I'm not getting open. So this is the syllabus. Okay, sir. So successfully we have completed what we are supposed to do today. It is getting open slowly. Don't worry. Yes. So these are the diagrams related to separating organic components. Oh. Yesterday we have seen the types of organic reactions in detail, methods of separation, sublimation, crystallization, distillation, differential extraction, chromatography. Sublimation, they have not given examples in the textbook, but I gave 3 examples: camphor, naphthalene, and benzoic acid. They can be separated from impurities. Crystallization is impure. The filtrate mother liquor contain impurities and small quantity of the component. This is one of the most commonly used technique for purification of solid organic compounds based on the difference in the solubilities of the compound and the impurities in a suitable solvent. Only the important compound which you want to separate should be soluble in water or in a solvent. You allow it to dissolve and filter and throw the impurities out. Then you evaporate the liquid, distill out the liquid to get the pure compound. That is the method. Distillation is a method, that is crystallization. Okay, sublimation, crystallization. Okay. Distillation is important method used to separate volatile liquids from non-volatile impurities, the liquid having sufficient difference in their boiling points. The vapors are cooled and the liquids so formed are collected separately. Chloroform and aniline are easily separated by the technique of distillation because the difference in the boiling points is so great. If the different components greatly differ in the boiling points, you use distillation. If the difference in the boiling points is very narrow, you use fractional distillation. That's the point. Petroleum components are separated by fractional distillation. Chloroform and aniline are separated by simple distillation. Please read the lesson so that you will be getting clarity. Okay, sir? This is the diagram showing simple distillation, aniline and chloroform. This is the diagram showing fractional distillation. This is fractionating column. The fractionating column can be of different types that can be filled with glass beads or it can be like bubble plate column. Distillation under reduced pressure, spent lye in soap industry is separated, glycerol is separated from spent lye in the soap industry by distillation under reduced pressure. Steam distillation is used to separate nitrobenzene, aniline from impurities. Please see. Differential extraction. If one component is more soluble in organic, solvent, less soluble in water, you take the compound in water solution. To that you add an organic solvent like carbon tetrachloride, shake very well. When you are shaking it very well, from water layer, it will enter into organic layer. When once it enters into organic layer, you use this type of funnel called separating funnel. Organic component in aqueous layer is there originally. We are pouring a yellow color organic solvent. Organic compounds dissolve in organic solvents but not in water. Therefore, from water on shaking it goes into organic solvent. Now it has got some green color. Now if you open the tap, all aqueous layer goes out first, keeping the organic compound in the organic solvent. If you distill the organic solvent, you get the pure organic compound. This is a differential extraction. Chromatography we discussed at length. Column chromatography, thin layer chromatography, paper chromatography, partition chromatography. We discussed, you need to read the book, okay?